This video, we're going to be answering questions on the circle theorem. So now we have this circle here and certain angles. Now we're asked to find angles DHG. So DHG, so it's this one here, and also angle EGH. So let me use a different color, sorry. Okay, so I've asked to find angle DHG, so which is this one here, and angle EGH. So are we going to do any calculations? Actually, no. Okay. It's actually going to be very simple. We just need to apply something called okay, hold on. Or what I will call the same segment. So let me just write it out. The same segment theory. Okay, sometimes I also like to call it the same arc theory. And what does it say? You know what, I'm going to type it out so that it's kind of easy to understand. So it's saying that, okay, angles in the same segment, okay, are the same. Okay, let me use the word inscribed angles. Let me use that word. Because you know we have the inscribed angles and the central angles, but then inscribed angles in the same segment are the same. Now, how does that apply to this? So we can actually draw like say a dotted line. Let me just put a line here and draw a line from this T to this G here. And just like that, we've separated this circle into two segments, a smaller segment here and a much larger. So let me use this color and a much larger segment here. And you can see that these two angles, now let me erase this. You see that these two angles, so this angle 42 here and this angle here, they are in the same segment. Okay, they are in this big space like this. Or you can also say that these two angles are, so hold on, sorry. You can see that these two angles are subtended by the same arc, which is from D to G. Okay, if you like this, same arc, you can see. Then we do like this, also same arc. All right, so these two angles are more or less the same. So angle DHG is also 42 degrees. Okay, that's why you call the same segment theorem because they are formed like at their base. Okay, if you look at this, if you look at this as a triangle too, okay, if you look at this as a triangle, okay, you can see that they have the same base. Okay, if you draw a triangle like this, you also draw, oh, sorry about that. It's not. And if you draw a triangle like this, you can see that they have the same base. Okay, sorry about the. So just mishmash. Let me do that again. Let me see which one. But you can see they share the same base. If you draw two triangles, they share the same base. Again, sorry. But you can see. So angle D GH is also 42 automatically. So you don't have to do any calculations. All right. So these kind of questions are just there to more or less confuse you. Okay, so what you can do when you see such a thing, you just you can draw like a line, you can form a chord. Okay. And how about angle EGH? So E EGH, this one here. So it's the same thing. We can actually draw a line here. Okay, let's do that. We can draw a line here. Oh, no. Okay, from E. Oh, it's taking a different color then. Why do? Let me see if I can change the color here. With black again. Okay. All right, so not perfect. Ugh, I'll just do it freehand. I think that'll be better. If we can draw a line from E to H, you can see that we have a small segment here. Have a small segment here. And we have a much larger segment. Let me use orange. A much larger segment here. All right, so these two angles, this one here and this one here, they are in the same segment. And if you want to draw like a triangle now, they have the same base. Okay, from here to here to here. Okay, and then from here to here to here. Okay, again, it's not perfect, but you can see that they both share the same base. You can see it in so many ways. They are in the same segment. They are subtended by the same arc. Okay, they share the same base. If you draw a line, they share this. So there are so many ways to kind of to make yourself understand it, but they are more or less the same. So it means that angle angle EGH is also 30 degrees. Okay, so we can clean this up. So this is 30, this is 42. Okay, can draw a line here to make sure, remember, you can see they share the same base. And this one too, they share the same base. So they're more or less the same. You can see them at the same angles or the same triangle. And then same with the other ones. Let me use a different color. Yes, orange. I'm just make it a bit thicker. From here to here to here. And then from here to here to here. So yeah, you can see more or less they share this. So they're in the same segments. They are subtended by the same arc, and they share the same base. If you were to draw them as triangles. So that's it for this question. Okay. All right, so let me go to the next one quickly. Oh, sorry, that's all right. Angle EGH, angle EGH is equal to 30 degrees. All right. So when you write, for example, sorry, only much further. When you write, let's say it's in an essay exam and asked to write this. So the way you do it is that, okay, you say, oh, let me type it out. So you can skip this part if you, you can say, okay, using the alternate segment theorem. You can state it if you want to state it. I won't just state it here. I've already stated it here. And then you can say, oh, let me just copy this first. Let me copy like angle. Sorry. For example, I can say angle EGH is equal to angle, so we said angle EGH is equal to angle EDH. EDH, and then angle DHG is equal to angle DHG is equal to angle DEG. DEG. So you can write something like, and then you can now say, okay, this is equal to this. So this is how you can, but if it's an objective or multiple choice question, just be quick about it and go to the next question. All right. Now this one, they only give us one angle here, and they would want us to find angle ADC, which is here, this one here, ADC. How do we do that? We can see what we have is like, we have a quadrilateral inside a circle. And not just that we have a quadrilateral inside, we have a quadrilateral, like the vertices of the quadrilateral are touching the circumference of the circle. So this is what you call a cyclic quadrilateral. Okay, what we call cyclic quadrilateral. Okay. Now for us to find, hold on, for us to find this angle here, we need to find this angle here. And how do we do that? We use this one. Okay. We're going to use the inscribed angle theorem first. Okay, it means that this central angle, okay, let me put this central angle in a different color. Use this central angle in blue. So central angle is 2 times the inscribed angle. So this angle here is 2 times the angle here. Okay, as long as they are subtended by the same arc. Okay, so what didn't I say is, well, why wasn't it 2 times the angle, let's say here? It's because, let me show you. Okay, this angle here is subtended by this arc. Oh, hold on, let me stop this into shape. All right, so this angle here is subtended by the same arc. You can see it's facing this arc. This angle here is also subtended by the same arc. So they're kind of facing the same arc. So it means that this angle is twice this angle. So if this is 172, 172 divided by 2, that would be 86. Okay, 86 degrees. So it means that this angle ABC would be 86 degrees. All right, so this angle here will be 86 degrees. Now we can easily find this, find the angle ADC. Okay, so we use that. Now in a cyclic quadrilateral, the opposite angles add up to 180 degrees. Let me just put a degree sign, sorry. So in a cyclic quadrilateral, the opposite angles, so the angles facing each other, so those like this angle and this angle are opposite each other, and this angle and this angle are opposite, they are facing each other. So they're facing each other. So it means that angle ABC, okay, angle ABC plus angle ADC should add up to 180. So 86 plus ADC add up to 180. We move this 86 to the other side. Let me move down a bit. So angle ADC is equal to 180 minus 86. What is 180 minus 86? That will be 4. Well, we're left with 17. Should be 9. Should be 94 degrees. That means our angle here is 94 degrees. Okay, so angle here is 94 degrees. Yes. Okay, so 180 minus 86 should give us 94 degrees. And that's it. That's our answer. All right, so it means that angle, so in the right angle ADC is equal to 94 degrees. So you can see we applied 2 theorems here. So the thing about this circle theorem is that you don't need much calculation. You just need to know when to apply these rules or these theorems. So I hope I've been able to explain these two. They are more common. If you have any questions, just let me know and I will try my very best to explain everything I can. So thank you very much and have a nice day.